continue with our lecture. On the next one, this is why renewable energy. So, 18 of the 19 hottest years since the record began have occurred between year 2000 and year 2019, and we are on track to lose many of our unique ecosystems, including the flora and the fauna, due to all these rising sea levels and also extreme weather events. Okay, so what are the extreme weather events? So this is a wildfire in Kangaroo Island, Australia. This was before. Okay, this was the image before. Look at all the green grass, and because of the wildfire, everything got burned. Okay, it was too hot, so everything got burned, and it took a while to put out the fire as well. And because of that, you can see the effect at the Australian capital in Canberra. Look at that, the scenes is all orange. You know, during the extreme weather, this is how it will look like. Of course, we are not in this space yet, but you know, in Malaysia we do have haze.
Not our problem,
yeah. So during extreme weather events, it could get very bad. Yeah. So this is an example of the increasing sea levels. Okay, in Kiribati. So 5 of the Solomon Islands have already disappeared beneath the waves. Okay, they've already been covered up. And if you are not careful, you know, the cities nearby us would be the next one in line. Especially those standalone like Singapore. Okay, so the effects of drought. This is Victoria Falls in Zimbabwe. This is the waterfall. And when it is having the drought, you know, this is how it looks like. Less than 50% of the average water fell over the falls in 2019. Okay, so these are the countries that have signed the Kyoto Protocol. Look at the red one, is also the one that is declined. And it's the US. Okay, surprise, surprise. Okay, so CO2 emissions, the dark blue ones are the ones that have the most CO2 emissions. So it's the two superpower, China and the US. Okay? And we also have declining supplies. So the fossil fuel is having a finite life. So we have an estimated of 300 years of coal remaining in the earth and 50 years of oil remaining in the earth. So after this amount of time, we are expected to rely on other fossil fuels. Just imagine if there's no oil, you have to rely on the electric cars already. Okay, those who are having the oil ICE will not be able to fuel it anymore. And as the supply diminishes, so does the cost of the fossil fuel will increase, and the price of electricity has actually increased above inflation in many countries, including the UK. So more and more people are falling into this term we coined as the fuel poverty. Okay, fuel poverty. So you have not enough to cover the cost of electricity in some of these countries. So at the same time, we look at it as a need, but there's also business opportunities. So it's opening for us new markets, new technologies, new job opportunities, and hence why you are studying this course today. Existing fossil fuel markets are dominated by large and well-established companies. So some of your seniors or seniors have all went on to work in some of these companies already, or maybe you have even interned in these possible opportunities that you may undertake. Okay. Oh, I know maybe some of you may be working in Solar West. Come the middle of the year. Oh, just a quick question: are you applying for a job already?
No. Now? No. I applied for the event job.
So why don't you apply now?
I applied.
You apply, right? I mean, by end of May you can start working already.
Yeah.
Don't want lah, sir.
Why not?
1 month holiday, then work already.
1 month you got no pay off.
It's okay, man.
It's okay.
Eat house one.
I want to
Enjoy,
enjoy
you can start applying now because it takes time to go through the interview process before you get the actual job. So if you apply now, I think by May you can start the
enjoy a lot of I start
So if you haven't considered, maybe you can start slowly looking. I'm not rushing you, but maybe you can slowly start to look. So these are examples of sources of the renewable solar, wind, wave, geothermal, and biomass. And the UK accounts for 3% of the greenhouse gas emissions, while accounting for 1% of the world's population. So they recommend the white paper to reduce the CO2 emissions by 2050 and 20% of the electricity from RE in 2020. Just now we saw the 97% RE production. That was not UK, that was Scotland as a whole. Okay. So we have seen this slide on the high concentration of CO2, okay, that has been very high since the 1950s, and is majority caused by our generation or the generation before us, but it will impact a lot on our future generations. Okay? So we have to make the active decision now, otherwise the future generation won't be able to enjoy the blue sky like what we are having in this lifetime. Okay? So can we change this trajectory? Well, we need all of the big players to be part, including the United States and China. Okay, so China is one of the main energy consumption by field. Look at the amount of coal that they have been consuming. This is until 2013, but the rise has been because of the growth in the Chinese economy. Okay, so for renewable energies technology, how we can mitigate the rise of CO2, one of it is the carbon sequestering. So the carbon sequestering is a long-term removal to capture and sequester carbon dioxide from the atmosphere, and this is to slow or reverse the carbon dioxide being emitted into the atmosphere. So instead of releasing it into the atmosphere, we are now sequestering it into the ground, where they will be captured and sequestered under all these depleted oil gas reservoirs, geological formations, soil amendments. Okay, so all these that require carbon dioxide will take it in naturally. So we also have created artificial methods to remove large amount of CO2 from the atmosphere. Okay, so this is the ocean carbon sequestering. So they have techniques such as seaweed farms, iron fertilization, or even depleted fossil fuel stores. Okay, so all these places are where we sequestered the excess CO2. Instead of releasing it into the atmosphere, we are going through such things. Okay, so one of the renewable energy source is solar. It converts sunlight into electricity, and the intensity of the solar light will cause variation in the production of electricity. Okay. Next is the wind. This is used. Okay, based on the wind, it will create a mechanical power inside a wind turbine and then turning the electrical generators inside. So, however, solar and wind are both intermittent energy source, and the UK is a good place for wind because it is rich in wind energy, particularly in the offshore region. Okay. As for hydroelectricity, is generated through the movement of the stored water. As long as the stored water are released, that movement of the water will rotate the turbine, and that will generate the electricity for the end user. Okay. So if we go for a cut through, this is how it will look like. You have your dam over here. When this water is released, you have the turbine all the way at the bottom to capture the energy caused by the flowing water from the high reservoir to the lower reservoir, and that will generate the electricity and then transmit it through your transmission lines here. Other than that, we also have biomass. So biomass is a plant or animal material, and usually is either grown crops such as wood or wastage such as wheat or manure. So it's actually transformed into pellets, and then these pellets are burned in biomass power plants. However, biomass is seen as also one of the contributors of the CO2 because it produces it. So due to that, some countries incentivize good food is incentive schemes. The good food is being burned as well. So there is a place to monitor because biomass is renewable. Because there are things that can repeat itself, but at the same time it produces CO2. So it's not really a good source contributing to the atmosphere. Okay, next is geothermal. Geothermal power is the energy captured from within the earth itself. So you have a long rod that is connected to the earth, and then this water would heat up, becomes the steam, and you will capture this steam to turn the turbine to generate the electricity. And this is good because you are not actually using any source to generate the heat. You are just tapping into the heat from the earth. And it's believed that geothermal energy could provide enough electricity for 10% of the world's population. Actually, this makes sense. So, why it makes sense? Because this is not reliable on the intermittency. So, if you are talking about sun, you need solar panel, you need to depend on the sun. Wind turbine, you need to depend on the wind. But for this case, the locations of the geothermal are typically known, so you would be able to expect the output of heat from these locations rather than predicting when the sun will come or when the wind will come and so on. So it's more stable. Okay, so you have also tidal energy, and this is a form of hydropower that captures the energy from the tides and create the electricity. Right? This is a very new and uncommon form of electricity generation. Previously, we used things like tide mill or potential difference, but now we have this tidal turbine. We'll cover more on this in the night. Okay. So we have also nuclear. So post-war, much of the world believed the nuclear would provide all of our electricity needs cheaply and safely. However, in recent times, the cost of electricity generated from nuclear is almost equivalent to those of fossil fuels. I think this part is wrong because the cost of uranium is actually reasonable and actually is significantly lower overall as compared to fossil fuels. Okay. But UK also have plans to open at least 6 nuclear power plants over the next 2 decades. So one of the concerns is that they perceive nuclear to be safer than other sources of electricity. Okay? Safer than other sources of electricity. But however, when they have issue, the impact is significantly greater. Okay? It's safer, there's less number of accidents overall, but when there is an accident, the impact and casualties from these accidents are not only causing these 30 people to receive the lethal doses, but many more people around the area died years later from the cancer due to the exposure to the radiation. Okay, so one of the example is in Chernobyl. Okay, you can look it up. And even recently, there's some of the major ones. When I was studying, there was also a major nuclear accident in Fukushima. Okay, so that was another instance. So one of the concern of nuclear is not the operation of the plant itself. The plant itself is considered safe. Okay, the plant itself is considered safe. Outside of these accidents, it is safe. However, the main concern is the byproduct of the nuclear. So when the uranium is burned, it will have this byproduct, and this byproduct is actually emitting the radiation. It's radioactive. Okay, so this nuclear waste must be stored safely and securely. But why it says generations to come? Because of the half-life cycle. The byproduct half-life cycle is hundreds of years. Okay, so means that it is radioactive for hundreds of years before it is half and half and half, right? So it is actually radioactive for a long time. And because of that, they are actually stored in these containers. These containers are not only, it's not like a water bottle. It has to be a lead container with 5 cm thickness just to store the nuclear waste. Okay, otherwise the radiation will seep out and it's not storing anything. So we are having these containers thick containers of all these nuclear waste, and you are going to store it, way under the ocean. So it's a uniquely long-lived byproduct of our electricity producing technology. So in essence, you are sacrificing the future anyways if you are going for nuclear. Okay, if you do not have enough of these containers, where do you store the waste? Okay, so if the Romans had used nuclear energy, one of the concerns is that we would be the one looking after their waste. Okay, but we get nothing for looking after their waste because the energy has already been generated, then it's not generating now. Okay, so nuclear has its concerns over there. So on the cost side, it is cheaper, but the long-term impact, you can't measure this cost. So in summary, for the renewable energy, you need to be aware of the broader economical, political, and engineering picture when assessing and designing renewable energy systems. So hold on to your engineering knowledge and scientific objectivity. Yeah. So I think